Good morning, class. Welcome back. Hopefully, you made the most of your catch up day yesterday. And today, we are going to be moving on. We're talking more about patterns of motion. And we are talking, before we look at the patterns, like how the movements that we see in our solar system and our neck of the galaxy, um, before we start applying those same patterns elsewhere in the universe, we're going to first look at them as close to home as possible. All right, we're going to examine the elements of those movements. Um, you know, and we're going to start with the movement of Earth. Okay, specifically the Earth, Sun, Moon system. Okay, now you can probably guess if you took some time to figure out what three planetary bodies are included in the Sun, Earth, and Moon system. They are, in fact, the Sun, the Earth, and the Moon. Yes, that may be on your test. I haven't decided yet. But within that system, we have two types of movements. We have rotation and revolution. Okay, and as you guys no doubt know from your vocab, rotation is like this, spinning, 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 and revolution is like this. Okay, and we know that the moon both rotates and revolves around the Earth, when the Earth also revolves and rotates around the sun. And the reason for that is it all has to do with gravity and mass. Now, gravity and mass are really important. They basically they map out everything for us when it comes to astronomy. Everything in astronomy comes down to gravity and mass, and those two are directly related. The larger an object is, or the more mass it has, the greater gravitational pull that it obtains. Okay, so it makes sense that the largest object in the system is going to have the most things revolving around it. All right. And when it comes to mass and gravity, the third member of that family would be distance. Okay. The farther away something is from that large object, the less effect the gravitational pull has. This is why the moon, even though it's in the Sun, Earth, Moon system, does not revolve around the largest object in that system. The moon doesn't revolve around the sun, it revolves around the Earth because of the distance between them. Okay. Planetary bodies will always revolve around the largest object nearest to them. Make sense? The Earth is the largest object nearest to the moon, and so it revolves around. The moon is the largest object nearest the Earth, and so it revolves around the Earth. The sun is the largest object around the Earth, and so it revolves around the sun. That wasn't always the belief, though. Fun story. Way back in the day, people used to believe that the Earth was the center of the solar system, and not just the solar system, but the entire universe. They thought that the universe was really small, and really small as in like smaller than the size of the solar system. And yeah, but it kind of makes sense, right? Because you're looking up in the sky and you're seeing the sun. It looks like it's making circles around you, the moon making circles around you. As you stare at the planets, it looks like they're making circles around you. But they also notice that sometimes you would have Earth and Venus, or Venus and Mercury. They would appear in one place, and then they would kind of switch places. And this wouldn't make sense if Earth was in the center. They wouldn't really be lapping each other as frequently as they would. But they do that because Earth is not, in fact, in the center, but 3 spots away from the center. There's a guy in the 3rd century named Aristarchus, I think is how you pronounce it, who first came up with it, but nobody really cared about science back then. So just kind of let it go. And then all of a sudden, a guy named Nicholas Copernicus came out with this, what he calls the heliocentric model, helio being the sun, centric meaning center. And he's like, hey guys, we've been saying the Earth is the center, but it's actually not. It's the sun, and I can prove it mathematically. And people who were in charge of scientific teachings back then said, Nick, shut up. You're not. No, you're wrong, dude. You're wrong. Like, yeah, 9 out of 10 scientists believe that the Earth is the center, and that means that the Earth is in the center. And Copernicus said, well, guys, science isn't democracy. It doesn't matter how many people you have saying one thing, that doesn't make it true or false. What does make things true or false is facts. And the fact of the matter is the sun is at the center. And they're like, shut up. And they killed him. True story, over like teaching science, over trying to tell the truth. Then it wasn't until a guy named Galileo who invented or who applied a astronomical use to the telescope, um, essentially used his invention to prove Copernicus. He published his work, and people are like, oh, okay, well, I think you're onto something then. And that is how, that's the very quick version of how the sun got to be, or how the main scientific conception got to be that the sun was at the center. Now, what I want you to do for your work today, I want you to read page 40, 41, 42, and 43. Okay, and I want you to answer some questions about this. I want you to have a really firm understanding of the Earth's movement around the sun before we start looking at the moon and the motion of other planetary bodies. That is the goal for today. All right, so answer the questions. There's not a lot. There's only like 4, and that should be it. And then tomorrow we're going to do something a little bit more fun. Okay. Till then, bye-bye.